Good morning. I'm Pansa Setia Utama. Our group will present two different studies. First, in the science and engineering about precipitated silica production from palm oil mill fly ash. And the second is an analysis of cultural content in foreign English textbooks, which will be presented by my co-presenter, Mr. Ian Grant. Even though our study is quite different, but we found common issues that have to address. First is how to use local resources for English teaching and precipitated silica production effectively. And the second is how to reduce amount of budget for importing English textbook and precipitated silica. And let's begin with our first presentation, which is my research. The title is Precipitated Silica Production from Palm Oil Mill Fly Ash. As you can see, silica is compound of one atom silicon and two atom oxygen. Even though the compound is the same, but the form of silica can be varied from quartz stone, silica sand until quartz glass. But the most widely used in chemical industry is precipitated silica. As you can see in this graph, precipitated silica used in many chemical industries, from automotive industries for tire production and mechanical rubber good production, cosmetic, plastic and polymer industries until printing inks industries. That's why the global valuation of precipitated silica in 2018 is quite high. It's around 7,000 million US dollar. And the market demand grew quite fast, especially in Asia Pacific region. The growth is 9% per year. All the commercial precipitated silica now in the market is produced from conventional process, which use soda ash and silica sand as a raw material. The raw material must be fused at a very high temperature, above 1300 degrees Celsius. That's why this process needs an expensive equipment and huge amount of energy. So many researchers try to find alternative way to produce precipitated silica. But in my opinion, the most promising raw material is aqueous ash. Why? Because aqueous ash contains silica in amorphous form, so can be extracted in quite low temperature, below 100 degrees Celsius. And the process is simple compared to the conventional process, but this process use large amount of chemical and make the process expensive and cannot compete with the conventional processes. In this research, I use local resources, which is palm oil mill fly ash. Why? Because now almost 90% of world palm oil production is from Indonesia, Thailand, and Malaysia. And the objective of my research is to develop economic viable process for precipitated silica production from palm oil mill fly ash. And the method is quite similar to the previous method. I just replaced the sulfuric acid using carbon dioxide. Why? Because carbon dioxide is cheaper and safer to the environment. Furthermore, the byproduct, natrium carbonate, can be processed back into sodium hydroxide, and sodium hydroxide can be used again to produce precipitated silica. That's why my process uses lesser amount of chemical compared to the previous process. And the result of my research, from 1000 kilogram fly ash, I can produce 200 kilogram of precipitated silica. And the quality of my products if compared to other researcher which is use the same raw material, palm oil, but different process. As you can see in this picture, my product is superior. If I compare my product with the commercial precipitated silica, it's quite similar. Based on the result of my research, I can develop process for silica production from palm oil made fly ash. Based on this process, I make an economic evaluation, and the result, the production cost of this process is lower compared to the conventional process. So the conclusion, the process developed in this research is promising and feasible to further develop into commercial production. This is my research, and next I will invite my co-presenter, Mr. Ian Glenn. Mr. Ian Glenn, time is yours. Thank you.